Okay, in topic 10, we're starting today. We're going to talk about circles more, and we briefly touched upon circles in topic 9, where you found the circumference of a circle. That was the distance around the outside of the circle, and we had a formula for finding the area of the circle, which was the space inside the circle. Okay, you've got a lot of definitions here on this first page that you're going to want to go through and make sure you understand. Okay, the first one is a central angle. It says a central angle is an angle whose vertex is at the center of a circle. So if you recall back when we originally talked about angles, okay, angles were created by two rays. Okay, this was the angle, this is the measurement right in here, that's what we're measuring, that's the angle. And this right here, that was the vertex. Okay, that corner was the vertex. So what we're saying about a central angle, this would be a central angle right here. Okay, the vertex of that angle, that corner, is right at the center of the circle. That makes it a central angle. Okay, an arc is a continuous portion of a circle between two endpoints on the circle. So from this central angle, an arc is created. That arc goes from the endpoints of that angle, of that central angle. So we would say that is the arc. When you have a central angle that's 90 degrees, and you'll see boxes again, so if you see a box there at that vertex, that means it's a 90-degree angle. If the central angle is 90 degrees, well, the arc is 90 degrees also. Each arc has a degree measure equal to the degree measure of the corresponding central angle. So again, if I have an angle maybe that's less than 90 degrees, maybe this is 45 degrees, if that's the central angle here, it's also going to be the arc measure out on the circle. Angle EAY is a central angle. We've already talked about that. Here's angle E, goes down to A, and it goes down into Y. The vertex, that center letter, that's the vertex, has to be in the center when you name the angle. Okay, and then we've got different arcs. We would call the arc EY. From E on the outside of the circle to Y, that is an arc. And we use this little arc symbol above the two letters. Okay, if I ask for the measure of the arc, it's equal to the measure of the central angle. They're both 90 degrees. Okay, some definitions here. A minor arc has a measure that's less than 180 degrees, kind of like an acute angle. A minor arc is less than 180 degrees, and a minor arc will just use two letters in its name. Okay, a major arc has a measure that's greater than 180 degrees, and if it's a major arc, you're going to see three letters used in its name. Okay, and the semicircle has a measure that's equal to 180 degrees. Okay, when we write the arc PQ, we assume we're talking about the minor arc. If you only see two letters in the name, it's considered minor. Okay, so on this particular circle, the minor arc from P to Q, we know if it says it's minor, it's less than 180 degrees, and I would just take the two endpoints. I started at P and I went to Q, and I put the arc symbol around it. Now, if I want an arc that's greater than 180 degrees, that's bigger than halfway around the circle, I have to use three letters. So maybe I'm going to go from P to S all the way to Q. Notice that I can go different directions around the circle. The letters tell me what direction I'm going. So if I start with P, I go through S, and I end at Q. That would be your major arc. You've got to have three letters in your major arc. Now, if you pass more letters, let's say I go from P to S all the way to T in that arc, okay, I'm going to end with the T. My two ending points are in the arc name, and I just need one letter in the middle. Even though I passed both S and Q, I just need to put one in there. It could be either the S or the Q. But if it's a major arc, you've got to have three letters. All right, the first thing that we're going to be doing with these arcs is you're going to be determining an arc length. It says we know that arcs have the same measure as their corresponding central angles, but to find the actual length, like how many centimeters is it, or how many inches is that, we have a formula for that. Okay, and it says that the arc length, what we're finding today, that arc length is equal to the number of degrees over 360 times the circumference of the circle. Remember, the circumference formula was all the way around the circle. So basically what we're doing is we're just taking that portion of the circle that we want the arc length to times what the full circumference would be. So in this case, if I'm finding the arc length, Okay, I would say the arc length is equal to the angle measure you're going to be given. So you'd say 120 degrees over 360. It's always out of 360 degrees because that's all the way around the circle. And then we take it times the circumference. The whole circumference, remember, was pi times diameter. So 120 over 360, those are going to reduce. They both end in 0, so we can divide them both by 10. And 12 over 36, that's 1/3 times pi. And then the diameter. Well, here's the radius is 9, so we know all the way across would be 18. So I can take 1/3 times 18, and that's where the 6 pi is coming from. And again, you can leave your answer in terms of pi, or we can plug in the 3.14 in for pi, and we could multiply that out and get the actual, not the actual, but the, we'd have to round it, we'd get the estimated distance, okay? Okay, let's try another one. I want the arc length of this bottom example. Got a couple of them here that I can try. Okay, so I'm going to use my formula. If I want this distance here from N to M, if I want to know what that distance is, I'm going to take the degrees, divide it by 360, and then I'm going to take it times pi times the diameter. If the radius is 10, the diameter is going to be 20. So that's the formula that I would use. I can divide these. They end in 0. Okay, so we can actually divide 135. Okay, it's going to reduce down to the fraction 3/8 times pi times 20 over 1. Okay, this isn't going to go in evenly. I could multiply straight across and get 60 pi over 8. Okay, 60 over 8, that's going to reduce. If I divide them both by 2, I get 30 pi over 4. Those reduce by 2 again. I get 15 pi over 2. Okay, I can leave my answer as 15 pi over 2. Or if the directions want a decimal, you can plug in 3.14. And the last one here, if I want to find the arc length from C over to A, if I want to find this distance, I take the degrees divided by 360, take that times pi, and then times the diameter. If the radius is 24, the diameter would be 48. Okay, again, when they both end in 0, you can divide by 10. 3 goes into 15 5 times, and 3 goes into 36 12 times pi times 48. This is over 1. Pi is over 1. So when you multiply straight across, you can do that. Or I can see right now that 12 is going to go into itself once, and then it's going to go into 48 4 times. So I can reduce before I multiply. Now when I multiply straight across, I get 5 times pi times 4, which is 20 pi. And then I got 1s on the bottom. Okay, so that's just going to be 20 pi. Okay, so you're using that formula for arc length on your first worksheet. You can do the 10-1A worksheet.